Um, these, these should be easy, but students think they're so easy that they cut all these corners and they get them wrong because they oversimplify them and they refuse to show any kind of word that is halfway them. So, bear with me and you will do them well if you just make yourself show a little bit of work. Right, Brian?
Of course.
Right on. Okay. The whole idea is dealing with definite integrals. There are rules for dealing with definite integrals. Some of them are new. Some of them are obvious. Some of them not so obvious. So it goes a little something like this. Some we already know. If you have a constant in a definite integral, what can be done with that constant? You can move it out front. Okay? That's a product constant, not an added function. What about if you have the sum of two functions? If you integrate a sum, you can separate them and integrate each add-in. Okay, that is absolutely not true for products. If you have a product, you cannot split it into two integrals. Then you have to do some kind of U sub or integration by parts you'll later see. You cannot split a product. All right, newer. What's the integral from A to A of a curve? Okay, what is it? I heard 0. Give me why. Give me one reason why. There's no area. Okay, if you think of this visually, it's the area under curve from A to A, which is no area. You could also, if you let capital F be the antiderivative of little f, then wouldn't this be the antiderivative of capital F at the upper limit minus the lower limit? And isn't that then obviously 0? Wait. This one. Okay. What about if you switch the limits of integration from A to B to then B to A? What happens? It is the opposite. Why is that? All right, well, let's go this way. Let's assume B is the bigger number and A is the lesser number, okay? If I go from A to B, then delta X is positive because I'm going left to right. However, if I go from B to A, then delta X is negative. Now, the only way that those are going to be equal then, if you switch the limits, is if you negate. They will not have the same area because the basis would be negative in one case and not the other. So, switching the limits of integration, it's negative. What about if you had a region from A to B, then added from B to C? What would the total of those areas be? A to C. Additivity. Think of a curve from A to B and B to C. The sum of those two regions would be the same as the single region from A to C. That's the additivity property, and it's pretty obvious. What is not so obvious and requires a little bit of review? There are rules for even or odd functions. Do you remember anything about even or odd functions? Super. Pre-calculus review them. Even odd is a certain type of attribute to some functions. Not all functions are even or odd. Some can be neither. In fact, most functions are neither. It's a pretty special case. A good example of an even function, for example, is x squared. If you look at x squared, that's an even function. The key to an even function is that the y result you get for a positive x is exactly the same as the y result you get for a negative x. 2 squared is 4, negative 2 squared is 4. You can see graphically there's symmetry at the y-axis. Now let's talk then about integrals. If I went from, I'm going to need to draw this again. Say you looked it up properly. If I went from, well, shoot, this is not quite, will you change this? Sorry. will you change this from negative b to negative a is what I wanted to say. Sorry. Now, we typically make b the bigger number. Negative b to negative a then would be this region of an even function. What would it correspond to on the positive side? Positive what to what? A to b. It would be the same as positive a to b of f. In both cases, delta x would be positive because you're going left to right, and the y values would be the same because f at negative a matches f at positive a and such. So going left to right in both cases with positive y values yields the same area. Okay? If you looked at negative b to b, this one I might have been expecting you to read my mind a little. That's not good teaching. But negative b to b, how would it relate to 0 to b? It would be exactly double. Double 0 to b. Because of the symmetry. Okay. Odd. What's another function besides x squared that's even? Give me a trig function that's even. Cosine is even. Okay, symmetry at the origin, cosine's graph is symmetric. Cosine of pi over 3 is the same as cosine of negative pi over 3. Cosine's even. Give me an example of an odd function that's a polynomial. X to the third, or even x to the first. Let's go with x cubed. The idea on odd is that when you put in a negative x, you get out the opposite y. Negative x yields negative f of x, or the same number but just the opposite sign. Okay? So the symmetry is about the origin. Okay. Now, if you talked about, again, this should have been, sorry, will you change this to negative b to negative a? Let's think. If you looked at an odd function and you took negative b to negative a, this region, how would it relate to the positive version from a to b? It's the opposite. It's the opposite of a to b. Okay? Because it's below. The y values are below, so the area is negative, or the opposite sign. By the way, I don't want to infer to you that the quadrants are always first, third. It could just as easily be 2, 4. And that's even. That's odd also. You with me? Symmetry about the origin could have two different pairs of quadrants. What about negative b to b? What's that? 0. Yeah, negative b to b would be one positive area, one negative area in some fashion, and so it would have to come out this way. All right. And then bounded ideas. These are a little less, yeah, actually, when you see them, they're pretty clear. So the idea is, if you know something about f, that the y values for f are only this big, then you can also make a conclusion about the area under f. For example, if you know that the y values on f are always positive on an interval, then what do you know about the integral, or the area under f? It has to be positive. If f is always positive on the interval, then the y values are positive. And assuming a is less than b, then this is going positive. X is changing in a positive way, so it must be positive. Okay. Say you had two curves. One is f, and it's always above or at most equal to g. Then how would the areas under f and g relate? Area under f is greater than or equal to, if I guess they were right on top of each other, area under g. All right, now this one requires a wee bit of thought. Say I told you that f of x was bounded on the region. It was bounded above by u. So draw yourself a f of x curve. Okay? Here's f. Now the upper bound on the interval from a to b is u. In other words, the function never goes above some point u. And it never goes below some point L. L is the lower bound. Then what could you tell me about the area under F from A to B, this green region? The area under F, what would it have to be bound above by? What area must it be less than? The what? Yeah, under U. What is the area under U? Which is, in essence, a rectangle. B minus A for the width times U for the height. In other words, the area under F has to be less than that blue rectangle. What about the area under F? What must it be greater than? The area under L, which is, I didn't give you enough room for it, I apologize, but B minus A times L. So it could be bound above and below. Now this could actually be super useful on a multiple choice problem. If you knew a lower bound and an upper bound in the function, you could automatically eliminate, well, it couldn't be that, that's too big or too small. So that's a handy test-taking skill. Now, using this requires practice. I tried to build it up slowly. So these are good examples of using one of these ideas at a time. A, B, E, F, and G are pretty straightforward. C and D require a little more thought. I will give you a second to think about those. Feel free to talk over, and once everybody's, or just about everybody's had a chance to do them, we'll go over them. And let's go through the first ones. I would imagine a lot of people, you could probably do this without error, but I don't want to miss any, so I play pretty safe. My work looks kind of, I guess I would do something like this. 1 to 5, take away 2 to 5 is how I'm going to find that. And I got a little corners in that I don't write the argument, assuming that it's only about f or g or just one function. If it has two different integrals, then I probably would write f and g. But at any rate, what did you get for this? -2. Good deal. Okay? This I definitely would probably do mentally, but the idea is that. So what'd you get for B? B? 20. We'll jump back to C and D in a second. What'd you get for E? -12. You're going to switch these limits of integration so it goes lower to higher. That's the opposite. So that's -12. Okay, what about F? 0. If F is odd, then the positive area and negative area perfectly symmetric should cancel out, so that's 0. And what about G? What'd you get? 12. It's positive 12 because the region on -5 to -2 would be equivalent to 2 to 5. So it is 12. All right. Now then, let's talk C. I guarantee you that on a multiple choice test, more than half the people would choose 12. Is that what you got, or did you get something else? What did you get? 18? I can't remember what I got, but 18 sounds like it's right. People get 12 because they say, well, screw the 2, I'll just say 2 plus, and there you go, 2 plus 10. Can you do that? Can you pull out a added factor? It's not like here where you can pull the 2 out front. I can't pull that out front. It needs to be integrated, and so it's this. What is the antiderivative of 2? 2x. And so that should be more like 10 minus 2. That's 8 plus the 10. So it is indeed 18. Ooh. What about the next one? You were going to explain that to somebody, you'd say you should use? No, you sub. You sub. Why would you use you sub? Because you have a function in a function. It's u sub. It's a u sub case. Okay. So if you let u equal x plus 2, then that means du equals straight up dx. Oh, that subs well. So the integral becomes f of u du. The limits have to change though. If x is negative 1, then u is negative 1 plus 2 or positive 1. If x is 3, then u is 3 plus 2 or 5. The integral then becomes the integral from 1 to 5 of f. Yes?
So I did that entire thing, except I didn't even realize it was supposed to be a u sub. So like I just went straight to the integral of 1 to 5 of f.
That is actually fine. You could do that. That's fine. You wouldn't necessarily have to show this.
Well,
So it is 10. Okay. The fact that it's u versus x does not matter. Okay. The curve would be generated the same way. Whatever the function is, square root of u graphs exactly like square root of x. It's the same graph. Okay. Would you then go to the back and try using pairs of ideas? That's where it starts to get a little harder. My best piece of advice to you is don't go too fast. Don't go straight to the numbers. Organize a little with calculus. Show a little integral work, and you'll make far less mistakes. Okay. What'd you get for A? 4. I agree with 4. Any questions on A? Okay. Cool. B. What'd you get for B? Negative 20. I agree with that. Any questions on B? None. You need to be able to do these on your own, so just writing my answer down doesn't mean you any good if you don't know where this is from. Okay. C. That was easy. 0. Okay, it doesn't matter how ugly the function is, there's no width to that region, so it's 0. D is a little more challenging. What'd you get for D? 58, 57, 55. I got 68.
I got 68.
Oh no.
Yes.
Okay, so let's do that one. I think we know that we need to split first of all, yeah? Okay, so that's cool. And I could have definitely made a mistake. Wouldn't you agree that this is a straight up integration of 1/2 x squared from 2 to 10? So it's half of 100 minus 4 or 48 for that first. Cool? Okay. This requires a wee bit of u sub, yeah? U is x over 2, so du is 1/2 dx, and therefore if I'm going to sub, dx is equivalent to 2 du's. 2 du's. The limits of integration would change from 2 to 10 to half of those, so 1 to 5. So this is going to change at the end of the day to 1 to 5 f of u times 2 du. 2 du. The 2 can be brought out front, substitute, and so at the end of the day it's 48 plus 2 tens, and that's where I'm getting a 68. Do you agree? Okay. What about E? What'd you get? 2. Yeah. Had to switch and then take apart. What about F? I did not get 0. Anybody else? Okay. Consider this, please. X cubed is odd. Yes? What about x cubed plus 1? Is it odd? Is that symmetry about the origin? Yeah, it is not odd. Okay. In essence, that's adding 1 is like x to the 0. and that's an even function, and you're adding an even or odd, it's not symmetric, it's neither. That's neither even nor odd in its combined state. What can you do? You can separate them. You should separate them so that you can use the odd. The odd only applies to f, not to some kind of f amalgamation. So the antiderivative of 1 is x from negative 7 to 7. That's 7 minus negative 7. That's 14. And that's 0. So altogether then, it is 14. Okay? And the last one, what'd you get? 10, 24, 12. I got 6. Okay, no. So now this, does 2x ruin even? Imagine cosine of x and cosine of 2x. Is cosine of x obviously is even? Cosine of 2x still even? Yeah, still even. Okay, in essence, it doesn't matter what this is. F is even, period. 2x, x plus, I could put x plus 7 in it, whatever. F is still even, period. Okay? It's only outside that it might change. So this is even. You do have a u sub issue, though. U is 2x. du is 2 dx. I don't have 2 dx. I have dx, so dx is 1/2 du. With substitution, and that becomes f of u 1/2 du, and the limits, u is double every x, so this would go from -5 to -1. -2, right, yes, good point. -1/2. -5 to -2 by even is equivalent to 2 to 5, and 2 to 5 is something, I can't remember, 12? And that's where I'm getting. Okay. All right. Do that last multiple choice. This is an AP multiple choice. Really, if you look at the distribution of answers, there really are only 2 answers that people will choose. Obviously, only one of them is correct. Make sure you choose it correct. Okay. Show of hands, don't worry about being wrong, but everybody must hold their hand up for one of 2 answers. How many say B? How many say E? You guys are really good. Sorry. I just assumed people would. That usually the idea is people just mindlessly just throw the numbers together in some fashion and hope it all turns out right. But apparently you actually thought about it. I don't know about you, but I thought 1 to 6 take away 4 to 6, yeah? Unfortunately, you don't have 4 to 6, so you have to do a little switching. But 1 to 6 is 15 halves, and 4 to 6 would be the opposite of 6 to 4, so that's the opposite of 5, so -5. So yeah, it is even. Okay. How do you know that works?
Because instead of subtracting,
You just leave it 6.
because then you have to subtract a negative, which is the same thing as adding a positive.
So you just said leave it alone and it's like support. Yes, that works. If you want to do it the easy way. Fine. All right. Questions on 55 and hopefully maybe a little bit of 56, but I definitely want 55 today. Questions on 55? If we have. 55. Yeah. 55 is not yesterday.
No, you're right there.
56. Okay. We did an AP in class practice. What? 4. Yeah. 21.
Number 16.
16. 25.
Possibly 23.
23.
If I don't.
Can I hear another one? Okay, cool. Let's do this. 4. 55, number 4. Here it is. Where did I put it? Okay. Oh, so none of these are really replaced. Okay, number 4. Okay, to do number 4, you have to be precise with your use of and also have to graph it correctly. Where does sine of 3x complete one arch? What's the complete period? Complete period is 2 pi over the coefficient, yeah? So a half period then would complete one arch. So pi over 3 I heard, and that's true. So you're dealing with the region from 0 to pi over 3 to get the area under one arch. Okay? Now the region and the area is just the area under the function. Dx is the bases of the rectangles. Here we go. This is a function within a function, so you should be using u sub. You let u equal 3x. Therefore, du is 3 dx, which we don't have. Our dx is just normal, so dx would actually be 1/3 du. So with substitution so far, I'm at 1/3. I'll pull out front, sine of u du. Now change the limits of integration. If x is 0, then u would be 0. If x is pi over 3, then u is 3 pi over 3's or pi. I am?
I think that we're given 3 sine 3x.
Oh, 3 sine 3x? Oh, you're right. Sorry. There is a coefficient out there. Does that affect the period idea? Does it still end at pi over 3? Yeah. Okay. So that 3 actually, in essence, then makes our life easier because then the coefficient goes away. Beautiful. Sorry. So this then is 0 to pi of sine of u. The antiderivative is cosine or negative cosine? Negative cosine from 0 to pi. Negative cosine pi plus cosine 0 is negative of negative 1 plus 1, so 2. Cool? All right, and then remember on a definite integral, you don't sub back for u. You change the limits to fit u, so you put them in for u. 21. Question on 21. This required you to translate English into calculus. Remember, one of the big ideas of AP is verbal connections to calculus. So, excuse me. So if it says f is a function whose slope at any point is twice its x-coordinate, how do you put that into calculus? How do you find slope at any point? It's the derivative. So what they're saying is the derivative, f prime, is twice its x-coordinate, 2x. They also tell you that it passes through 1, 1. And they want to know what the function is. Well, let's start here. How do I get rid of the derivative? You integrate this. F then is x squared. I pick up a c because there's a whole family of functions that have a derivative of 2x. X squared plus anything shifted would always have that slope idea. But we pick up the 1, 1 and put that in to use to find the c, and in this case c must be 0. So the function is just straight up x squared. That's slope twice its x at any. That make sense? So that, the gotcha in there is the verbal connection.
If I was 16.
Okay, anybody else need 16? Okay, 16. All righty. You should definitely, well, actually, eventually in second semester you'll have two ways to approach this problem. But right now we only have one. If you try and evaluate this limit, you get 0 over 0. As a calculus student, you should always be wary of that being, maybe is this a derivative idea? Remember, the whole idea of a derivative is the idea of saying, hey, change between 2 points approaching change at a point. And that is very much what's going on. When I see that, I think, okay, so this is the slope between 2 and some other point on the E curve, and then getting the points closer together. This is the ultimate definition of the derivative. And so it's the derivative of e to the x. You first have to say is what function, and then say at a point, or generally, in this case, it's the slope at 2 they want. So that's e to the x at 2. That's where they're getting their answer. Is definitely not done algebraically. You don't try and evaluate the limits. The idea is you recognize the derivative. Okay. 25. 25. I'll just warn you here. These are questions I often take points off on the homework because students feel like, oh, it's just easy. I'll just choose A, B, C. If I don't see a ton of work in this, you didn't do the problem. Okay, there's no. I did a ton of work here. You have to do. It's an optimization problem. I know it's at the end, so it feels like, oh, it's not. It's an optimization problem. There should be a gobble work, calculus work, not calculator work, calculus. So here we go. The sum of the squares of two positive numbers is 200. Okay, I'll let the numbers be x and y, so the sum of the squares is 200. Cool. The minimum product, I want to minimize p, which is the product of the two x, y. All right, so this is an optimization problem. I'm trying to find a greatest or a least case. You don't do 2 variables if you can, or 3 variables if you can avoid it. You do 2, or 1 independent variable if you like. So I could say that this is x times root 200 minus x squared. Also, I'll pause to this and say, please don't assume these are whole numbers. I see all these people doing different cases. I'm trying 1 and 2 and 3 and 4. Nowhere in here did it say they're whole numbers, okay? If you're trying cases, you better pack a lunch, baby, because there are infinitely many cases in there to try. You're not going to get this by trying cases, okay? They don't have to be whole. So I need to find, to minimize this, I need to know where p prime goes negative to positive, where it stops decreasing and starts increasing. So let's go with this. P prime is first stays the same, derivative of the second is 1/2, that to the negative 1/2 times the inside derivative by chain rule, so negative 2x, plus second stays the same, times the derivative of the first, which is 1. I need to know whether this is 0 or undefined for my critical numbers. I'll get a common denominator. The common denominator, did you divide out that 2 or leave the 2? Did you see that 2 going away or not? I'll divide it out. Okay? So then the common denominator is root 200 minus x squared. And this would be negative x squared. And this, when I multiply it by the common denominator over itself to get the common denominator, it becomes plain old 200 minus x squared over the root. I still need to know where this is 0 or defined. I get 200 minus 2x squared over the root of 200 minus x squared equals 0 undefined. This would be undefined undefined. P prime is undefined if x is square root of 200. P prime is 0 if x is 10. In terms of signs, let's see, for small x's, positive over positive. For big x's, bigger than 10, this would still be positive, but that's negative now. Now that kind of sucks. Because it went from increasing, the products went increasing until they started decreasing. So I expected that critical number to be the good one, but it actually turns out that that's bad. So that's a max. I get a greatest product of 10. So the minimum, wouldn't it be one of these two guys? They wanted me to minimize the product, right? Did I read that correctly?
Yes.
Oh, gotcha. So then, the minimum product is
The answer was B,
yeah.
which is sort of stupid. That is stupid.
Because the math doesn't do that.
It promptly
The math
didn't
is-
give you an ability to know if you did well.
Yeah. So here's the, wow. This is a really cool problem. This is pretty awesome, I got to say. So if I were to graph this curve, what does it look like? Downward opening parabola, I think. It looks like this, but the endpoints are not defined. And the reason they're not defined is because if x is 0 or root 200, oh yeah, no, that works. Actually, x could be 0. Did it say they were positive or no? Positive, so it can't be. So it actually cannot be positive. It could be that. Oh no, because if x is that, then y has to be 0. So that can't be it either. So the graph of the product looks kind of like that. And so this is actually a great introduction to absolute minimums and maximums. What's the absolute minimum value of that function? Almost, but not quite. Now you can see where that would present a problem. It's the one right before that. Well, that doesn't really exist. And so this has no absolute minimum. And so it has no minimum product. It's not defined at the endpoints. This is actually a great question. However, I'm so glad you asked this. I think I just mindlessly blew through this in the key. I don't think I saw the complexity of this question when I did this last night. So there is no answer. It has no minimum product. So it's E.
Good morning, Dublin Jaguars. Please rise for the Pledge of Allegiance.
And I chose math.
Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
That's a really good question.
All students, junior high school students, that you're taking the Healthy Kids Colorado survey today, you have been required by counseling for some hours. Please report to cafeteria for some hours today, and thank you for your participation.
Remember, the Junior High Student Council is holding a candy strike that will end this Friday the 6th. Your days are limited, so bring in your candy. Here are our selection to donate candy.
Oh, okay. Does anybody else need 23?
Check the table by the front office today for block and down items.
Sure.
The South Institute of Design and Merchandising from Los Angeles and the University of North Colorado from Greeley will be conferring today for 7 hours.
Sign up is not beyond paths to renewable scholarship opportunity is offered through the Computer Science Department at the Colorado School of Mines. High potential STEM student with financial needs interested in computer science could apply. 31st, 2018. More information is
Western State Colorado University is offering a new scholarship to hire 2 high school leaders who have participated in the high school student government regardless of income, GPA, or test scores. The application is in Johnson.
Thank you to everyone who donated to Operation Christmas Time. The winner of the House Cup, the House that Greg with 360 points is Ravenclaw. Congratulations. They were closely followed by Hufflepuff with 266 points, and Slytherin with 247 points. Gryffindor came in last with only 10 points.
Final care packages don't phase out. Make sure final care packages in order for you. They will be ordered and delivered to the purchase on the Jetco Feed website.
I just lost everything. I'm not sure what happened.
Don't miss out on this fundraiser in the high school fundraiser.
Senior high students. Seniors, November 15th may be the next deadline for your college application. Be aware of the college deadline system and accordingly.
Sorry,
Take note that senior holders early application deadline is November 15th. Please be right behind it with the December 1st early application deadline.
Okay, you can use elimination then.
There will be an intake meeting for girls soccer right after school in the cafeteria on Thursday, November 3rd.
The first day of winter sport on this Friday, November 10th. Morning courses athletic either 2 at 8 a.m. or 4 at 8 times. Please see Mrs. Resist paper.
All right. 55 should be turned into
Have a
that.
great day.
56 you may keep with me. All right. Do-do-do.